Tak dobrý den, dobré dopoledne. Já vás vítám na druhé sekci naší konference mozek, ještě, šanci. Ráno jsme se bavili vlastně o tom, jaká jsou rizika spojená s umělou inteligencí, od těch rizik, řekněme, globálních až po ty technické detaily, které jsou skryté vlastně a ví o nich jenom ty zasvěcení. A teď bychom se chvilku začali bavit o tom, co s tím můžeme dělat, jaké jsou vlastně nové možnosti. A prvním řečníkem je Najah Nafach, kterým jsem se seznámil na studii NATO Industry Advisory Group. A Najah přišel s velice zajímavou myšlenkou vlastně využívat blockchain nebo technologii blockchainu k tomu, aby jsme chránili umělou inteligenci, jednak teda data, ale i senzory a další věci. A já jsem moc rád, že tady Najah je, protože to, co ten nápad považuji za velmi užitečný. So please, Najah, floor is yours.
Hello, do you hear me? Yeah. Okay. About the slides. Shall I activate the slide? Yeah. Okay, well, good morning, everybody. Thank you very much for inviting me to this conference, and I do the observation that I am the first one to speak in English, so I'm sorry. I can speak in French also if you want. Well, nevertheless, I'll try to be explicit. It's not my native language, but I think I can manage it. Thank you. And also, I would like to thank the speakers this morning because they gave a lot of criteria and parameters that makes me think that blockchain and AI can be complementary, can help each other, and particularly blockchain can help AI solution because blockchain is a solution within, embedded in the background. You don't see it, in fact. Okay, so the summary of my talk is going to be around data. We talked a lot about data, and it seemed that there is a big problem in data. You know, what has been mentioned before was around security, how to secure data access, how to make how to make data inalterable or inattackable by someone who is intruders. Now, there are data issues which are different that I'll talk about. And data need to be accessed. Now, who can access the data? He needs, or she needs, or an object need to have an identity. And there has been a lot of discussion about identity with voice, which is not human, but it's synthesized. So those issues are something that we need to tackle. Having talked about the issues, I'll highlight and remind the audience, maybe you don't know about blockchain or you know something which is superficial based on cryptocurrency and things like that. But I'll give the technological view on the blockchain and the potential that it can represent. Now, when blockchain is combined with AI and IoT, because IoT is the fundamental elements that capture data, the total set of the technologies can be of high value and generate a lot of value within the solution. Now, it's easy to state this, but there is an implementation problem. There is an architectural problem that need to be defined, and it's not that easy. So I'll touch also on the architectural aspects of the solution. Now, there are cases around DID. DID means decentralized identifier. It's like a URI, universal resource identifier, but it is assigned to objects, it is assigned to data, it's assigned to people. And when we understand the potential of DID and how it is anchored or created by various blockchains, we can think of a first layer of trust that can be implemented to support all the solutions that we have talked about this morning. Then there is the case of decentralized data and data monetization that allows individuals, data creators, small enterprise to monetize their data and to get fair compensation instead of having all data being collected in large storage system and big internet giants who are collecting the data. And finally, I give an example about the new movement economy, which is the mobility, the cars, the vehicles, the roads, the battery, the autonomous vehicle. This ecosystem represents the most advanced and the most evolved in the technology aspect that I'm talking about. And they set the scene for a very good, complex and sophisticated solution that leverage all those technology together. And then there is some conclusion. Okay, as we all know, modern society runs on data, and artificial intelligence extracts value from this data. And the more this data is important, the more the decisions are accurate, and the more the model is rich, and the more benefits will go to society and to business. Having said that, there is something wrong, which is that data which is collected here is mostly sits within the big network giants who are Amazon, Alphabet, Apple, Facebook, and Microsoft, to name only a few. And you will see that this is not because you've heard about it, in newspapers, but really it's a big danger because we are creating dependencies on those giants, and we are creating vendor lock-in, what we call it, because you are connected to those clients and your solution sticks, your ID stick with those giants, and there is something wrong. While you have startups, small companies, academics, universities, they have AI expertise, and they are starving for data, and they don't find it easily. And you have other enterprises who have data, and they have less AI expertise. So there is something wrong, because if you get those entities to meet together and to make them able to share their data, the equation could change. But at this point in time, the equation is really not solvable in the right manner, okay? I'm sure that you have seen this picture. It illustrates the fact that data is the data in 21st century is the oil of the 20th century. It's definitely true, because with data you can create a lot of values and revenues. And those are the big giants that are sharing data. And because of this, they are the most richest company in the world, whether in selling IT, selling services, or selling advertisement. And no one can beat them. They are unstoppable. This is a long list of how they collect data. When I'm talking here, my phone is on. Apple is listening to what I'm saying. When you are at home, you have Alexa, you have your iPhone, Amazon, Apple are listening to you, and they are analyzing your conversation. When you call a doctor, you do a medical exam remotely, you exchange with the doctor, he sends you a prescription, the prescription goes into the network giant storage, and it's being leveraged. So you are the product. But you get benefit from all those networks. However, your data is under their control, and they can leverage it, they can sell it, they can do whatever they want with it. When you get a copy of the slide, all this list makes sense, and really it makes you think about, shall we continue in this direction? Shall we keep our data available and make it under the control of others, or how we can get back control of our data? The other side of the problem is that those data storage producers, they have also the power to give you identity. Your identity today is your email ID, your email address provided by Google. You have a lot of, I don't think that there is an identity provider today which is not connected to those network giants. And the ID, as we have seen, is really essential to get you access to the data. So your ID is also under their control. Now, the problem of identity in the network, like we are here in face-to-face meeting, we are like 60 or 70 people. We see each other, but in the network there are billions of people connected, and computers and devices. So your identity is not really something which is tangible, which is verifiable. And this picture illustrates the fact that on the internet, nobody knows that you are a dog. I mean, it's really an extreme illustration of the metaphor that beside the network, identity can be anything. You know, it can be a robot, it can be a program, it can be someone who is imitating your identity, someone with voice who is imitating your voice. So there is something which is wrong in identity. Now, this picture comes from, I think, 2 years ago, but it's still valid. It shows that among the 7.6 billion people, individuals around the world, there is 1 billion who don't have any identity. And there is like 3.4, 3.2 billion, some who have identity, but in paper. There is no digital trail behind their identity, and others have some digital trail with their identity. That means you have your passport, but you still have some electronic ID, some kind of electronic ID which is associated to your passport or to your normal ID card. So what is the solution? We talked about data, we talked about the identity vagueness and the dependency. The solution is that every single object, every single individual, every single data which is created and has value need to have an identity. And this identity need to be secured, need to be associated with cryptographic keys, need to be associated with credentials. And those credentials need to be in an identity hub which is under your control and not someone else's control. And this is the big revolution. If it doesn't happen, we will continue being dependent on big providers. Associate credentials, democratize data. That means I can share data with anybody here who is interested in the data I'm producing, and vice versa. We need not to post this in Google and then do the share through Google. It's easy to say, but it's something that we need to look at. Proof of ownership. I mean, this is like what has been said this morning about AI. We need to prove that this data belongs to someone, and this someone has the certificate to say that I am the owner and nobody else. And I'll come back to the solution which could be based on blockchain, which allow this. And authenticate the source. At any single point in time, we know that this data is not fake. It has been produced by someone. We know his identity and we can check it, and has been transformed by other people. So we know all the life cycle of the data. And this can be done with the blockchain. Abandon data consumption, compensate data producers. Any producer of data, whether it's music, whether it's art, whether it's, in general, it's digital. If it's a physical item associated to the certificate, that's another story. But when data digital is produced, the producer has to be compensated in a fair manner. So, in order to make this work, we have 3 components of the solution, and this is a simplified diagram of the foundation of the solution. You have the IoT that perform data capture. You have the AI world that do 2 things, learning and then inference. And you have the blockchain providing trusted data and trusted application, providing registration, sharing, and monetization. And when I say that, they are provided with what we call smart contracts, which are programmable, small program hooked on the blockchain, and they execute under certain event. They are unattackable, and they belong to their creators, and they can be used on and on in a 100% reliability. And you can put them off, but it's difficult to attack them, okay? So that's the way things work. Now, in terms of how the infrastructure that support those three boxes is being developed is something that comes back to who is providing the infrastructure, or raise the problem, who is able to provide the right infrastructure to make all those things work together. And I'll come back to this later. But the three pillars that I have indicated can work in the context of smart city, in the context of mobility, in the context of healthcare, industry and military operation, and many industry segments. You have the same picture, capturing data through IoT devices, processing them in a learning phase and then in an inference phase, and the blockchain providing the right trust pillar. Now, this is the hidden problem that I did not raise in the beginning, which is I raised the data problem, ownership by the big giant. Second, the ID providers, the big giant provide you the ID. And here, the hidden problem is that the infrastructure also is provided by those giants. There is no way. In 6, 7 years ago or 10 years ago, people were wondering, shall we go to the cloud or not? Cloud is not ours. We need our data center. We need to control our data center. And the more and more time passed, people realized that going to the cloud is really very efficient, economical, and you have a lot of services which are provided by cloud providers, so people start moving to the cloud. But who are the cloud providers who are listed there? Whether they are centralized, distributed, public, private, hybrid, whatever. The largest one are Amazon, then Microsoft Azure, then Google. Those are the three cloud providers who have more than 80% of the market. Globally, not in one region. I mean, in every region of the world, you can subscribe to resources on Amazon, Google, or Microsoft. And I don't think that anyone in Europe can beat them. It can be an alternative for like a local cloud, because your application does not require a lot of resources at a global scale. You are not a large company. You have local players. For instance, in France, we have OVH, Scaleway. We have 3, 4 players. But this is the problem. Now, AI, when it comes to inference, cannot all the time go back to an infrastructure which is in a public cloud, and could require something called the edge cloud. The edge cloud is bringing compute near to the data. And I think here we have some opportunity to provide infrastructure by European providers to support local or where data is collected, where it needs to be processed. However, the edge cloud should interact at one point in time with the public cloud in order to exchange data, to do more processing or very high level, high performance computing and things like that. So this is, again, another dimension, and that's a simplified version of the total solution end to end, from capture to processing and supporting this with trust layer. Now, a zoom on a blockchain. Blockchain is associated with the Bitcoin. It works since 2009 on the Bitcoin blockchain, and up to now it's still working. What it is a database with multiple copies that are synchronized. That means the same copy exists on thousands of computers. For those of you who have been doing IT since 20 or 30 years, we know very well that distributed database is a very complex solution and cannot be provided easily. With the Bitcoin, we have been able, I mean, not we, but the community has been able to illustrate the fact you can have a copy of a database and it can be demultiplied in different computers around the world on thousands of computers. Now, this database is really cryptographically secured. I mean, everything is signed. Every transaction in the database is signed by its creator, and every signature is checked by a validator, and all the transactions in the block are validated, and they are linked all together, which means they are linked cryptographically. You cannot change one bit in one block, in one transaction, in one block, among all the blocks that have been created. So that's really fantastic. Now, how it's working by consensus. I mean, every single block that goes into the database, it is validated by a miner. And when the miner validates the block, he gets some fees. And all other miners check that the validation is okay, and they start working on the other block because they want to succeed in validating a block and get fees. So they are incentivized by money. And this part of the story has never been introduced in IT solution before, because from a technical point of view, there's no new invention. It's a collection of multiple techniques in cryptography, distributed system, peer-to-peer protocols, but the additional creative thing that has blockchain Bitcoin has added is the consensus between validators to agree on the state of the database and move to another state. And this is agreed because of money, because they want to win new Bitcoins. And that's makes us think that if we want to build decentralized solution in the future, this is the most challenging part, is how to make the database accepted and synchronized between a community of users by some incentivization. So that highlights something that we need to think about. This is, how the blocks are linked together, and this is why it's called the blockchain. Every block has the hash of the previous block, and the hash is calculated by miners who need to have extreme power, and they're generating a lot of energy, consuming a lot of electrical power, but they are being compensated because every 10 minutes a block is validated, and they got 6.25 Bitcoin multiplied by $40,000. That makes a good amount of money. So behind the scene, this is a picture of how the blocks are cryptographically linked, and you cannot destroy them. So now where we are now, we are at the level of, in the Bitcoin, we are at, in 18 million Bitcoin that has been generated. But we are today in two words of the blockchain, what we call permissionless blockchain, where anybody, you and me, can download the Bitcoin blockchain code and be part of the network. And this is called permissionless type of blockchain. And here, you cannot be attacked. If someone behaves badly, he is ejected. So it works with consensus, and the more there are nodes, the more the system is reliable and resilient. Now, enterprises decided to have their own blockchain, and they cannot reach the scale of permissionless blockchain. So they decide to have a few nodes and connect those nodes and have a consensus which is not based on incentive. It's based on proof of authority, or very simple algorithm in terms of Byzantine fault tolerance. But the problem with those blockchain is they were not successful because they are a bit centralized, because it comes back always to a few, a small community deciding on the state of the blockchain. So you need to know that there are two types of blockchain, and they are competing, but this one, permissionless, is the one which is successful. So the state of the blockchain today, the Bitcoin has a store of value and payment. There is around 18.8 million Bitcoin that has been minted, and what is left is like 3 million Bitcoin to be minted. Ethereum is another platform that came after the Bitcoin platform. It introduced the concept of programmable blockchain, where you add smart contracts to it, while in the Bitcoin blockchain, you only do value payment, and you have your balance sheet in the database. Now, the application that are really booming are decentralized finance, that's called DeFi, and NFT. And NFT, it's really something that AI people need to think about. NFT mean non-fungible tokens. Tokens which are not exchangeable. I mean, $1 is a fungible token, but a painting of Picasso is not a fungible token, is non-fungible token, is a unique piece that you own, and when you own, we give you the NFT. And this non-fungible token is a certificate of property. And you can sell it if you want, but when you sell it, you lose it. The buyer will have the NFT. And what's happening today in this world, funny world, is that NFT is booming. There are some digital art which has been bought with $69 million. And what has been bought is not the piece itself. I mean, because the artistical digital, you can see it, anybody can see it, anybody can copy it. But there's only one person who has the certificate of ownership. And this person can trade the certificate. Tim Berners-Lee, who wrote the HTTP when he was at CERN, he transformed the first piece of code in his program into NFT, and he sold it. So the NFT is really a very good concept that can be associated to some important data within the AI field. And data set within the AI field can also be transformed or described as NFT, and ownership can be transferred or can be given. So this is what's going on. So we have a problem now because the boom of NFT, there is a big fees which are spent in Ethereum to validate the transaction. Because Ethereum, like the Bitcoin blockchain, requires that you pay validators. 5 minutes? 2 minutes, okay. So I've been requested to shorten the talk. So there are more, I mean, I'll stop on the blockchain because for those who are interested can come back to me and ask some question. There is only one thing that I want to point at is that in Europe, with all those blockchain together, in Europe we are having some infrastructure which is European that's being deployed, and it's the same problem. Like we are so much dependent on those big blockchain, and there is nothing in Europe to support the administrative service, so there is an initiative in Europe to do that. Okay, well, since I have no time, in terms of the ID, the decentralized identifier, the problem is that we have this SSO, you know, the single sign-on, where you access a server by giving your ID, which is Facebook ID or LinkedIn ID, and this is really something wrong, because the same thing, those people, you are locked in. If they disappear, you are not able anymore to connect to the server you want. So we introduced this DID, which is decentralized, no central authority. When you create it, you don't create it through a central authority, you create it through a blockchain which is available to you. It's persistent, it stays with you all your lifetime. It's a cryptographically verifiable. That means you can prove with your keys that you own this DID, and no one can question that. And it is resolvable. That means when you send someone this DID, this someone can go to your DID document in which there are some cryptographic keys that can be used to check that you are the one who is controlling the DID. So with those four, we solved the problem of the identification. There are a lot of use cases which are described, and I urge you to look at the W3C recommendation on verifiable credentials, so you see that all use cases are described and can give you ideas about how they can be used. If two people connect together, they don't know each other, they exchange their DID, and they agree to talk, they can establish relationship in peer-to-peer manner without going to any server. And this trust model, if you have a diploma degree and this diploma degree has been issued by a university, the university associates the DID to this credential, it goes to you, and when someone asks you for your diploma, you send the diploma, the verifier look at the DID who issued this diploma and he check, and he read the public key, send the public key, and make a validation of it. So verifier and issuer don't talk to each other. The holder send the document with the DID of the issuer, and the verifier is able to check it. And it's really a trust model that is super and that can work in a very important manner. Now this is a stack, trust over IP stack, because people discovered that this layer can be provided with blockchain, and individual can talk to each other without any central authority with the ID exchange. There is a trust model which is here to check like the credential is valid, and you can have other workflows and other trust model depending on business process that we have. And on top of this, you have a complete ecosystem that can be built. So this is, remember that trust over IP is a foundation, and it's looking at an architecture that can really introduce a revolution in the solution that we try to deploy. Okay. Well, thank you very much.
I'm sorry, but